Austria. Richard Ljuhar is the CEO and founder of ImageBiopsy Lab, and he's in a completely different sector that he is going to come up and tell you about. He's got his 8 minutes, he's got his +2. So for those of you that have questions, get ready to fire those out now. He's ready for action, yeah? Sehr gut. Von Österreich, Richard Ljuhar. Thank you.
Thank you very much. Thank you. Good, yes. Well, I came far away from Austria to give you a quick overview about our company. So we are a health AI company, and what we do, we apply machine learning tools for an X-ray-based prediction and classification of osteoarthritis. And to set the stage here, allow me to just quote here the former president of one of the largest radiological societies in the world. It's the US-based RSNA. And what he said, actually in May 2016, was that he predicts that within 10 years, no medical imaging study will be reviewed by a radiologist until it has been pre-analyzed by a machine. And this is really the main motivation of our company. What we have developed and deployed is a vendor-neutral software for an automatic detection and classification of bone disorders based on conventional X-rays. The goal here is to use our algorithms to improve diagnostics, the accuracy especially, and of course to reduce the time it takes for a physician to look at these X-rays and decide if you're healthy or not, or in what stage of the disease you are. If you look at knee osteoarthritis or osteoarthritis in general, why do we pick that? Because the cases are just exploding. We're getting older, we are less active, we're gaining weight, everything contributes to more people being affected by the disease. As you can see here, the question is, how do you differentiate between early OA, late stage OA? How do you track the progression? Because what physicians do currently is they just look at X-rays and then they try to find out where you are. Now, the use cases, as I said before, are huge. There are roughly 40 million knee X-rays just in Europe, so you can imagine how many cases of that are happening here in Asia. If you also look at the time it takes for physicians to look at these X-rays, actually this takes quite some time. So we just came up with a rough estimate actually, which is roughly 8,000 weeks per year. That's what physicians spend just to look at knee X-rays and try to figure out if you have OA or have no OA, if you're progressing, if your treatment is working, etc., etc. And this really is just for the knee. I'm not talking about the hip or elbow or spine or the likes. Now, if you then think about, well, if it takes so long, then physicians have to work faster. Sure, but as the ACR here found out is that if they have to work faster, the error rate also increases. And we did our own study where we just gave physicians who just came out of the office a couple of X-rays and asked them, tell us, does the patient has OA, no OA, what stage? And we found is if you ask 3 physicians, you get 3 different assessments of the disease. So this has showed us that there is a paradigm shift needed. We have too many cases, it takes too long, and the actual way of diagnosing is not accurate enough. For that purpose, we have here developed our algorithms, which we use for an anomaly detection. Basically, we have the input, image comes in, and we have trained our networks and algorithms to detect certain anomalies, and then also identify healthy, non-healthy areas within the knee, and also in which stage of the disease the patient actually is. And how this looks like, you can see here basically. So to the far left side, you see here the scoring. So basically, this is a clinical score, which is considered the gold standard in OA. It's not being performed because it's way too elaborate, it takes too long. However, our software can provide this score in real time to the physician. So the image comes in, and the physician opens it, and the score is here. Now, if you compare it to how it looks currently versus with our software, here to the left side, you see actually here an diagnosis, which I actually took from a radiologist. I can just read through a few. It's just said, pain on both sides, knee OA both sides, right more. So this is quite vague, and you as a patient, actually, I wouldn't be happy to get that diagnosis. In Europe, most of these things are already proudly paid, so this is not really satisfying for the patient. And versus to the left side, you see here our standardized disease report, which gives here a very detailed explanation of where you are within the disease, what grade, all the different parameters. So, but we're also looking into other fields, let's say like predictive analysis. We're looking here in the first here knee replacements, where we use our software to take knee X-rays and hip X-rays. And please keep in mind, these are X-rays, not CT or MRI. And we just use the X-rays here really to predict certain changes within the bone, which are indicative that a certain replacement might be not healing right, or all these kind of things. Now the idea here is to use the software to go from a purely visual inspection, which is happening right now, and then you have a knee X-ray or an X-ray in general, and you say, well, I don't see enough, I need a CT, MRI, to enhance the X-ray and use our algorithms to really get more information on the X-ray. The information is here, really just to provide it to the physician to potentially replace some of these redundant image analysis methods. Now, a few words to the team. We are quite a diverse team. We're coming from all kinds of applications. I myself have a background in engineering, but my CTO is a molecular biologist. Then we have finance guys within us. And of course, Stefan is our orthopedic. And we have a couple other physicians which are helping us actually in analyzing the images. Where are we right now? To the left side, you see here we started in 2012 with the product development. In 2017, we actually went to the market with the first product, which is running at radiologist offices and orthopedics. We have a couple of very interesting leads in the US to use our software as part of OEM systems. But currently, we are still focusing mostly on clinical studies to use our software there and the German-speaking region of Europe. 2018, we're going to go to the market with a web-based platform, complete our 2A certification, and then expand the market. And then going onwards from 2019, 2020, we are already in an investor round to increase our funding to actually upscale our product. So new applications, right now it's mostly knee, but we know we need to also look at other anatomical regions and potential diseases, just like, for example, osteoporosis, fracture risk prediction. And then also launch in the US 2019, and then onwards 2020, the Asian market, where we have here in Hong Kong already a very strong partner coming from the field of pharmaceutical treatments. This actually was my last slide. I think I've ended within the time, right? Andrew?
Yeah, you got time for Q&A. You're good to go.
Yeah.
All right.
Thank you.
There we go. Thank you very much. Let's get into the Q&A, people. All right. This young gentleman who's, even from that thumbnail, I can see he's handsome and brilliant. He's got a question for you, and he wants to know, like, when you bring this in, it's like the best idea in the world. The managers are like, yes, we love it. It's going to be fantastic. The doctors are like, no, wait a second. Are the doctors, when they see this coming, the doctor's going to look at it and be like, no, the computer doesn't know what I know, and it's going to take me out of a job. Do you get resistance from the medical community versus the management technology community? How do you, what's your experience of that?
Very good question, Andrew. So yes, of course you get that. So that's the whole question of like how to position this whole AI thing, right? You can't go to a physician and tell him, hey, I have a computer, a software, which I've trained on 150,000 X-rays, and he's better than you are. You can't do that.
Yeah, ouch.
So you have to position it in something, hey, guess what? You save time. You can talk to to your patient. You get a standardized report, all these things. And that's when they start buying in and they start liking it. But you got to be very careful initially how to present that.
Okay, very important. There are several similar X-ray diagnostic algorithms. How is your business proposition unique? Good question from Karen Monasinga.
Very good question. Yes, so there are actually quite a number out there. So far, to my best knowledge, I have to say, in orthopedics at least, there's nobody as far as we are. What is our USP, or why are we ahead? It's really just the ground truth we built over the last almost, 10 years, and the framework we built behind that. So I think in orthopedics, we're very well positioned, but of course there are other applications in lung cancer screening, very popular in the US. There are a lot of companies out there. But orthopedics, to this date, we're still ahead.
Okay, and are you going to stay in that niche, or are you going to branch out?
Well, we see that the bone diseases are still something which is a small but very lucrative area.
Sure.
I'm not sure if we really want to branch out in a broader range of X-rays because others are out there and they're far ahead of us.
Okay, quick one. Training data for the algos. Where are you getting the data?
We got it from a couple of large US studies and also European data.
Okay.
Clinical studies.
Okay, fantastic. And still feeding into the machine.
Still feeding into that, and it takes a lot of time to get physicians to reanalyze that and give us the ground truth.
Okay, and there we go. We hit the 0 mark. This is Richard Ljuhar all the way from Austria from ImageBiopsy. Thank you so much. Richard, well done.